about the approaches and the possibilities of this technology. And this lesson is designed by Dr. Tyler Davos and my person, and I have the task and the honor to give this lesson. What is the starting point of all that, what I will show you in the next minute? The situation during the planning and construction of buildings is in most parts of the world the same. Means the architect develops drawings, makes plans. In most cases, these plans are two-dimensional, but the technical crews have to have three-dimensional models because they construct their technical systems in this way. The same we have for the calculations. The last days we had the discussion in the different lessons what we need to perform such calculations, simulations, and at least also the energy passport for building is also a three-dimensional network. The problem is every crew, every technical crew has its own database. They collect the data within their drawings on sheets of paper, Excel sheets, and so on. And the problem is everybody has his own data, but we have no interface to exchange the data between these groups. And we always have a situation during the planning process that we are discussing what is the right value for that what we are doing. The starting point for us is depending on also other points, the development of the calculation method. If you look what you have at the moment to calculate the building, you have standard equations, standard methods to do this, but we see it in modern times. If you want to design energy efficient buildings with good effectiveness, you have the problem that the methods don't work. The other part is we become more and more complex buildings, and for this you cannot use this method. Yes? And you see some pictures there. It's the airport from Frankfurt, the soccer stadium in Munich, and the castle in Dresden. These are some projects which I have made in the last 20 years, and where I had the requirement to improve the calculation methods. The most of them are simulations, because we have time-dependent processes, we have time-dependent influences, and that means at the end we cannot use static calculations. The other part is, if we do this in this way, we have a lot of data, and how we can manage this data, what can we do with this data. And that's why we taught the last years about the possibilities which we can use, which we can include in the planning process, and we developed different simulation methods. First of all is the calculation of the airflow around buildings and the airflow through buildings. Until the last 5–10 years, the computational fluid dynamics, which is used for the calculation of the airflow around buildings, is coming up. Until this time, the pressure distribution at the surface of buildings was estimated by measurements in wind tunnels. And now we have the situation we are faster if we do it with the computer. And depending on the pressure distribution, that is out over pressure, flu is under pressure, we can calculate that what happens within the building. That means we generate a so-called node mesh system, and dependent on that, we can calculate what happens, for instance, in the Terminal 1 in the airport in Frankfurt. We include in this calculation the situation on the entrances. You know, if you have an airport, there's always traffic from the persons from the outside to the inside of the building. You have always the situation that you have airplanes and the gates open, and that means at the end the building is open from the entrance to the gate, and depending on the wind which you have on the facade of the building, you get an airflow through the building. And this airflow through the building influences, for instance, the climatic situation and influences smoke distribution in case of fire. That's why it's necessary to know it. And third point is the infiltration is one important point for the heating load in wintertime. What we can do with this, we do not estimate the air quantity which goes through buildings. We also can define the quality which we want, which we need for the facade, for the door. Okay? And if we define something, we have the possibility to control it, because we say what we want. Depending on that, we know the quality of the facade, we know what we have to do on the entrances, and now we can calculate the terminal load of a building. Terminal load, everybody knows it, has different components. For instance, solar, lighting, persons, technical equipment, ventilation, air movement, and the transmission through walls and windows. And in Central Europe, it's coming up that the calculation of terminal load is done by terminal building simulation. That means we make models of the building. We have each room included in this model, in this three-dimensional model, and then we calculate the terminal load over the whole year. And that's what we see here in this diagram. Red is the heating load and blue is the cooling load. And we have this information for every hour in the year. That means we can analyze what happens in the building during the year, during different situations on the outside. With that, we have the possibility to improve the physics of the building, and we can analyze which parameters are necessary, which parameters are helpful, and we can show that they work. That's the important point. If we have defined the facade with the airflow around the building and through the building, and we have optimized the physical parameters of the building, we have to prove that the system which we choose is on the right way. In most cases, there are a little mistakes in the design of the system, and if the building goes running, you feel that there are problems. And the new possibility with plant simulation is that you can estimate the behavior of the technical equipment in front of construction and of running. That's very important. That means you take, like you see in this diagram, the heating load and the cooling load, put it through your technical system, give the control parameters, and then you can show how the system works. And you can define the control algorithm for the building. And that is very important, because we find on the construction field, if the engineers come and want to program the building control system, that these are colleagues from the IT, from the computer. They can develop software, but they don't know the processes of thermodynamics and fluid mechanics. That's why it's necessary that we have this information. This information can only reach with such simulation. In this case, we have an air conditioning system, the exhaust fan, the heat recovery, the heater, the cooler, and the supply fan. And these are the control parameters. And at the end, we can calculate what happens and works the system well or not. If it is done, we know the quality of the facade, we know the optimal parameters for the building, we know the components of the system, we are sure that the system will work well. But what we not know at this point, reach the energy, the air, the point where we need the energy for the air. That's the question. And for this, it's possible to perform airflow simulation, so-called CFD, computational fluid dynamics. There you can estimate, for instance, for such a terminal building, the Terminal 5C in London, the temperature distribution in a height of 1.50 meters around the floor. Over the whole terminal, you see the higher temperature on the lower side, there comes the sun into the room. And you can estimate the air velocity, and depending on the air velocity, the temperature, the turbulence, the surface temperature, you can predict the thermal comfort which you can get in the room itself. It's a system which is most commonly used to optimize airflow, because also ventilation has an efficiency. In most cases, we discuss only the efficiency of fans, of pumps, and other things, but also ventilation has an efficiency, and that's why we use it. I can give you an example in the next step, but before I will show you an example of airflow simulation, because I think the most of you, and also the most of you which are online, have never seen an CFD. In this example, we have an exhibition room where the supply air comes from the ceiling, wherever they decide this to do, but in this case it is so. And the exhaust air is near the ground. And now we research this room in the airflow behavior with CFD. And one result we have on the temperature and the air velocity and so on is that you can show how the air moves through the building, through the room, and that is shown in this video. Yeah? Yeah? You see the air comes near the ceiling into the room, the left side goes to the middle of the room, the right side flows along the wall down, and now you can say, or can analyze, works the system well, is it okay or is it not okay? And then you can change something. And you can change it in a way that the system works in the way you want. And the accuracy of this calculation is very high. For museums, we have to guarantee that the calculated and the measured value difference not more than 1 or 2 centimeters per second. And that the temperature difference is not greater than 0.2 degrees centigrade. Yes? And so you can imagine that the system or this calculation method is very good and that you can do a lot of things with it. The other topic also uses CFD, computational fluid dynamics, is to estimate the distribution of smoke in case of fire. We become more and more stronger rules for the maintenance of buildings. We have to be sure that the people are inside the building can come to the outside in case of fire. And especially if you have public buildings with long bays, you have to make sure that they are safe. And one method to do this is perform fire simulations. We have here an example. It's the airport in Frankfurt, the Terminal Hall B, and we have there a fire. And I have in the upper part a plane along this yellow line, and you see two different cases. The upper case, you have an air quantity for the smoke extraction system of 400,000 cubic meters per hour, and in the lower part, 200,000. And what you can see, or what you have to compare, blue, dark blue, is only part where you have no smoke. Everything what is not dark blue is smoke. And if you compare these two cases, you see that you get with the half of air quantity a quite better result. The same result we have if we look for such a plane on this side, and you see 400,000 as the upper plane and 200,000 the lower. It depends on the efficiency of the airflow within the room. That's why we use such methods. And the last years, we calculate, for instance, the new Terminal 3 for the airport in Frankfurt. And with this simulation method, we can decrease the air quantity which is necessary for the smoke extraction by 3 million cubic meters per hour. 3 million. That means only invest 20 million euros, which you have saved by this calculation. We don't speak at this point to the running cost. Yes. Yes. Okay. The next is a typical calculation for the planning process is flight simulation. And the last point of all is the measurement. It's today also already a known method to control what happens. The right picture shows a smoke test which we have done in the airport of Frankfurt. With that, what I have shown, we have a toolbox where we can answer all questions which we have in buildings. We can analyze difficult situations. But the problem is, if you see this, it's parallel, it's a standalone system to the typical planning process. The problem, we have no interfaces to the planning process. And that's what we have done the last 4 years. We developed interfaces from the simulation to the normal planning process. Why we do this? The simulations become more and more fixed part in the project because a lot of calculations now simulations, and that's why we have to look how we can include them in the process. That means on the other side, I told you this at the beginning, that we have a lot of data and information, and now we have to look how we can handle it. And now the answer is BIM. BIM is the answer on that, what we have to do with the data and the information. What means BIM? BIM means Building Information Modeling. Yes? It's a model-based strategy method to do something during the planning process. Important is model-based. That means I have a model, and with this model, I have a method, I have a strategy, what I want to do. Yes? And the system is built by defined elements, and it's like an object-oriented language if you program, make programs. Yeah? I will show you this on the example of a door. What we see on the left side is the 2D projection of a door, like we know this since years. The middle is a 3D version of the door. It's that what we typically have if we have 3D models from the architect. And the right is a BIM door, you can say. What is the difference? The difference between this and this is that you have the parameters on the door. You have the parameters on the door. It's not necessary that you have the information on a sheet of paper. You can add it on the door itself. That means if you look to your model, you go to the door, you see the information. And depending on this object strategy, every element, window, wall, can have their own information. So that means on the other side, BIM is not a software. It's not a software product. You cannot go to the shop and can say, I want to have a little BIM. Yes. BIM is a strategy, and you can use software which is able to take part in this process. Yes. And that's quite different of that what you can hear on the market. The software industry tells you, buy my product and you have BIM. That's not right. You have to have the model and you have to have a strategy, and then you can make BIM. Yes? The basis of BIM is a file format like PDF or doc or other things. It's called IFC, Industry Foundation Classes. It's a file format which is developed since the end of the 90s, and the last version came up in the year 2013, and it has a lot of new things, and the development is organized by the international working non-profit organization Building Smart. They are located in all places of the world, and they organize this development. If you decide in your project for IFC, you have the brightest, the most basis for that what you want to do, because you can work with all programs which can read and work with IFC, and this strategy is called Open BIM. That means open, everybody can take part on this process with his own software. The only requirement is that you have an interface to the IFC. What you have to do if you want to implement such a BIM process in your planning process, you have to analyze what happens, and that's what you do. You have to prove the possibilities. For that, what you want to do, you have to develop a process, and an important point is you have to clear the interface. That's the biggest problem which we have at the moment, that we have not enough interfaces between the programs and the different steps. Means at the end we have to develop interfaces, and at the end you have to bring this technology step by step in small groups, and from there to the whole process where you need it. I show you in a short way what we have done. It's not necessary that you find the right definition of all steps. It's necessary that you find a definition which is used in your company, in your organization, and everybody understands the same process. If we start the planning process, we have the collecting of data. In our case, we have the visualization of the data. We have the calculation of the load, the analysis of the load. We have to choose the technical equipment, the dimensioning of the system, the construction, and clash detection is a very important point. And at last, the tendering, and you have to organize the offers and the timetables for the construction itself. So it's a whole workflow from the view of a technical engineer, and now I will show you some parts of that. Collecting data, I discussed it some minutes ago. You can put all information what you have to every place in the building model you want. Means you put, in this case, the light intensity as a value to the room. You put the number of people which you have in the room as an information there. And important, you can show every value you have in the model. Every value. There are no limits. And it's a central part and point of this strategy to have the possibility to show everything online. Yes? And if you take your mouse and move the mouse over the model, the room which is under the mouse will highlight it, and you get a table like this, and you see all information from this room. Yes? In some cases, like we have done in the last years, you have up to 1,000 information only as a room. That's too much. That's why you can define filter sets. You choose your variables and you say, okay, I want only to have this one. And then you go with your mouse over the rooms and you see only this one, what you have chosen. Yes? You can also use this technology to find something. If you have large buildings, there's a question, where is the room? Yes? If you have buildings with a lot of technique, you have always the discussion, where are special rooms? You can also combine information. In this case, I want to find the profile storage. But not only storage, the storage rooms, I want to find the storage rooms in the level 0, and I want to find the storage rooms, they are larger than 50 square meters. And if you see this, you can combine a lot of information to get the result for your building. And so far you can increase your process because you get the information faster. I told you that the visualization of the information is central part. You can also go to the building itself and say, these are the types of building usage. We go to the storage, and all storage rooms are shown in the building. And now I can go with the mouse to the rooms, and if I click there, I get all information. So you see, it's possible to handle very fast the information which I have on the object. It's not necessary to look to tables, to sheets of paper, and to search where is the information. For all what you want to do, it is necessary that you have a process, that you have a workflow. And that means if you look to the calculation of the load, you have the own process. And you have always to look what is the input, what is the output. In our case, we use a BIM server as a central element where you find the IFC models. And from there, we transfer all information by a mouse click to the calculation program. And if the calculation is done, we transfer all information back to the BIM server so that everybody who is in the project can use this data independent from our calculation program. That means at the end, you include all parties in your work. And if you have an interface, for instance, in the direction of programs like Alpha, you can include this process until the maintenance of a building, of the running of the building. Yes? And that it works. Show this example. This is a hospital in Frankfurt on Main. This model has more than 3,000 rooms, and at every room we have more than 500 information. Yes. The second example is the exhibition hall, the new exhibition hall of the state in Frankfurt, nearly 1,000 rooms. And the third is the largest model which we have at the moment. It's part of the new Terminal 3 in Frankfurt. this model has nearly 4,000 rooms. And all the information which we need are on this model. And we transfer this model to the calculation program, also the data to this calculation program, and bring the information, the terminal loads, back to the model itself. An important part, if you have such objects, is the analyzing of the data. And you saw the hospital in Frankfurt. The calculation over 1 year gives you 80 gigabytes of data. And now the question how to handle 80 gigabytes of data. There is no commercial program which can handle such things. We developed a database evaluation system where you can include all this information and can get online the information what happens in the room. We include also typical evaluation strategies. For instance, to see how is the distribution of the cooling load in the building, how is the distribution of different load components in the building, and also the information about statistics. How often I have temperatures with 24, 25, 26 degrees, and so we can discuss how the systems work and have the temperature over that what we have defined. This gives us the possibility to be faster than ever before, because in former times we had the calculation and we analyze it step by step with tables. Here we have a computer system with a database. Depending on the situation that the IFC file format is an object-based model, you can also create your own elements. We spoke about airflow through buildings, how you will show someone what means it that there is an airflow through buildings. You have a lot of information. And depending on the fact that IFC is object-oriented, you can create your own elements. In this case, we create arrows depending on the flow direction, the quantity, and place them in openings and doors. And so you can use the model, including the data, generate new elements, and can show what happens. I told you that we combine the simulation with the planning process. We have an interface where the heating loads and the cooling loads come to the design programs of the engineer, and they have then the only task to design their ducts, their pipes, and their technical equipment. The good thing is they have all data and can read them about interfaces into their system. If the systems are designed, a very important point is to check the clashes, what you have. Yes? And the clash detection is included in different programs, but you get the information like shown in this picture. You get only the information. There is a clash between electro elements and air ducts. You have no information how many clashes you have, and you have no possibility to control what you have done. BIM gives you this possibility. We add the information from the clash detection as a property to the model. That means you go to the model and you say, show the clashes. And if you choose, in this case, this clash, the model is moving and the clash comes to the middle of the picture of the window. And then you see here is something, and then you must make it transparent, and then you can look to the inside what is here. And so it helps step by step to improve the process itself and to come up faster. And last, the engineers have to make timetables for the construction of a building. In Until now, it was, I will say, a not so good job. It was terrible because you have a lot of processes. You sit down and write everything and hope that the time frames are correct and that you don't forget something. Now, time is only one information on the construction element. You can write on a wall, the wall should be constructed between February the 1st and February the 10th, and the wall can be constructed after this and this happens. And I have here a small example where you see the model and you see the element, and then you can say, okay, that's the time frame for the element and the thing what happened, what is necessary before is also included. And if you go to programs like MS Project, you can read this information with the, over an interface into MS Project, and you get the time frame automatically. If you change something here, you can write this information back to the model. And so you have it on the model itself. At the end of the day, it's not only that we have the time frame. At the end of the day, we can also generate videos where we can show how the construction of a building goes forward. And this is that what is shown in this video. What we have done is only that we use the information on the element and then we go the time forward. Yes? And now you see what happens. And if you are on the construction field and have to control that the process goes forward, you can take this and can say, okay, where we are now. Yes? And this is also possible for the cost control, because every element costs something, and if you know that the element is built, you can say, okay, the money has run. So you see, you can do a lot of things with that, but it's not only that you have the information as a model, you can also put documents on it. Everybody of you knows you write a lot of things. You have a lot of files, and at the end of the day, you cannot remember where is the file. And if you have a planning process, you have a lot of information, you have a lot of protocols, you have a lot of documents, and the question is always, where is the document? Yes? And now you can use this technology to put the document on the model. In this case, we go with the mouse to this room, to this entrance area. It's highlighted. Then you switch to document and you get shown which documents are available for this room. You click on this document and the document is open. That means you can place everything on the place where it's necessary. And you can found it because it's the normal way of doing. It's not the computer way of doing, it's the normal way. We look, we want the information, and we can do this. At the end of the day, we have a central database with BIM. We have the central information. We can use this for information and communication within the project. We can use this for the simulation and the design of the technical equipment, and also important for the project management. Depending on that we have the information at the central point, we have one point where we can say there are the right data. That's the truth. Yes? And if you need something, you go to the system and take the data there. Yes? And what we get we get a process during planning, we get a process during construction, and at the end of the day, depending on this process, we are faster. A lot of objects, some of them I have shown you, work in this way. First, everything is calculated, then the information is given to the planning process. The planning process is controlled, the construction is controlled, and we go with the information from the plan simulation in operation of the building. What we have, I explained it, we have a central data management. That means at the end, we have also the possibility to control the data, because they lay on the system and we can select them, we can control them. We can also look, has the technical crew give us the information. Very often we get the information that they say, I give it you. You get a letter. Now you go to the model, look, it's empty or you have a value. That means we can control the process, we get a better quality of the planning, of the construction, and at the end of the day, we have a higher efficiency for the building, and we have better results in energy consumption. And in most cases, I will say the owners and running teams are glad that they have such possibilities, because their costs go down, the efficiency go up, and the most things go in the right way, and you have not so much problems like we have had in the past. That's all for today, what I want to show you. I hope you can understand that the development of simulation is necessary to answer a lot of questions for buildings, and that BIM is the right answer to handle all the data, all the information which we need for the planning process, and that this technology gives us a lot of benefits and possibilities to improve our work, and at the end of the day, we are faster and better. Thank you very much for your attention.
You have question? Before discuss our technology, I want to introduce our guest. Our guest come from Košice Technical University. This is my colleague, people department of electrical communication, and please question.
Too much information.
My idea is very good and fantastic. Before you, we planning simulation, and during enterprise this control technology.
Yes.
But for information, in Russia, Parliament of Duma now discussing law project of including BIM-technology for standard, for your standard.
Yes. Your country, you have.
Please, presentation your company for business and your Mr. Fogel in father of metal. Father of metal. Okay?
One of the fathers. There are a lot of fathers. Yes, the question is, what happens in your country, what happens in other countries? I can say the BIM technology is coming up all over the world. At the moment, BIM is the most common technology used in Australia, in Scandinavia, and the United States. And the European Union defines that since this year, BIM has to be tested in public projects, and BIM has to use until 2020. In your country, you have the implementation of BIM as a central strategy of your country. If you read the program 2050, Kazan 2050, there you find some points about BIM and the including of such a technology. That's what we are doing now, is we start the information, the education here in your country about this technology at the universities and the companies, to give you the knowledge to use it. Yes, and it's just starting here.
Please present. I am student. I am my name. Please go. Please finish. Please.
The other participants want to see you.
Please ask. Please.
Yeah. Okay.
I am.
Stay here. You are there.
Only this conference is but internet. And
So about training, for our. My name is Kirill. I'm thinking of. I'm student of arms.
Yes.
So I have one question about training, online training, courses for.
At the moment, yes, we have different courses. At the moment, they are implemented only in Germany and in German. Yes, and we discussed how we can do this in your country with which possibilities. And I think within the next year we will have such possibilities to do this. Yeah, because it needs time to prepare. Yeah. Okay. There any other questions?
please, the question on Russia and the Kazakh language. Please, you have okay. I want presentation of our guest. Now the stage of group. He will start from Ministry of Economic of Kazakhstan. With our guest, with Жанар Тайбасаров.
No, you can say something.
Я также приглашена сюда для того, чтобы познакомиться с технологией, для того, чтобы данные знания применять на практике, учитывать физические решения нашей страны. И думаю, надеюсь, что все это будет возможно. I hope that the knowledge that Professor Fogel is giving here will be understood and supported also in our country. And I wish for students that learned now different subjects will use it in their future in Kazakhstan. Thank you.
Your job conference now we participate our colleague, PhD doctor, Mr. Mikhail Belois. Still in our university, our students were lecturing, were speech. And I have some questions about well, for example, we have a heat exchanger in this tube.
Yes.
Can we use this technology for the calculation of the simulating process into this tube? For example, flow, temperature, maybe some speed.
Yes. That's what simulation methods what I have shown can be used to research what happens on heat exchanger, for instance, or heating plate. It also the strategy can also be used to design the heating element in the room. It's part of the whole process. My colleagues do this at the moment. They take the heating nodes, have the heating nodes on their on the room as elements, then they go to tables and can choose the heating element. And so they have the information there. And in future, we will have the situation that you can read all the parameters of the heating element on the internet. In the emulate, only product allowed now, only product allowed which can give the information via internet. And that means at the end, you take the load to your program, you define what you want, the type or the size of the element, and then the system searches in the internet and takes all parameters from there. Size, time, and otherwise, whatever.
I want to ask, thank you, my colleagues who are organizing this conference and the visit of my guest, Mr. Adamat. Okay, please present our guest and together question and
Yes, Professor from Slovakia, Mr. Professor Alexander.
Yes.
My mentor, my previously.
Yes, yes. Yeah, okay. It's the easier part of the job. The easiest.
So we have to work together.
Work presentation.
I hope Professor bring us his experience, and bring us his knowledge, more knowledge from his own experience, from life experience, and we hope our department bring a lot of experience, a lot of knowledge.
I am sure that we will do that.
I'm sure. Good morning, everybody. My name is Michal Kolkun. I am from Technical University of Košice in Slovakia. I am head of the department electrical engineering. I have many students, and finished 25 student PhD. Our department, my area is interesting is process and control. You develop them, something program, something in power in Germany, and and so on. This time I is a professor in university and something lecture for renewable energy and consultation like business students.
Thank you, Mike. Thank you very much. Please, we show is international program. My opinion is it's technology very interesting, fantastic. But in the future, maybe now, okay, we begin now. We sign agreement, and our university and the university and company who present this project, we begin working for technology. Okay, please. Well, this question
Now you are outside. Everybody is.
Hey, thank you. Question in Russian. Можно спросить, сколько времени ушло у вас для разработки такой интересной программы BIM? И много ли у вас молодых ученых, которые вам помогали? How many times took to develop this program, and did young people start to part in this thing?
Okay. What I have shown in my lesson is development of nearly 20 years. I start my work on this field at the beginning of simulation, and we can do only a part, small things, little things, easy things, and now we develop all calculation methods in the direction that we can calculate all buildings. 20 years ago, I can only calculate rooms, single rooms. Now I calculate all buildings. This work, I will say, is nearly finished. There are always possibilities to improve the calculation methods, to be faster, to be better, to increase more and more. But now we are on the process that we include the simulation in the planning process in BIM. And at this point, I work with a lot of young people because they are interesting, because they are very good in computers and very fast. And if they get an idea, if they get a direction where they have to go, they develop their own way to do something. And depending on that, it's very nice to see how they influence the development of such a process. That means at the end, young people are welcome to do it, to work on this field, and to work with BIM is not so difficult, not so strong a team. My colleagues need only some weeks to work with this system to control the planning process and everything what is together with it.
Thank you. I understand very transition and this technology, this technology program, not say soft, not soft program. This technology, this program is developed. It is demonization of all the program. please, about this opinion, ask my colleagues, my friends, and professors who have assigned.
Come online.
Уважаемые наши студенты, наш гость рассказал вам о стратегии BIM-технологии, включая будущее, это программа, она программа или система, в целом, она будет, скорее всего, вам, молодым людям, которые будут заниматься большими проектами, делать большие расчеты. Я просто хотел поблагодарить доктора Форга, что он специально наше предложение откликнулся. Это один из передовых способов систем, которые сегодня применяются в промышленности и в строительстве. Здесь такие расчеты. Это очень сложные расчеты. Сюда входит все. И теплоэнергетика, и освещение, и отопление, все. И как видели на слайдах, он показал. И самое главное, здесь не только расчеты делать, выходит документация полная, в том числе все документации между собой коррелируются, исправляются. Масса таких документов решается автоматически, практически, которые каждый из вас долго-долго делает. Поэтому я считаю, что такой вот организация труда и в будущем будет очень интересно изучать, от этого упрощает все, всю вашу работу. Поэтому учитесь хорошо, все, наверное, желаем такого. И, естественно, конечно, подтягивайтесь. Спасибо за внимание.
Я swim processor and Mr. Ford, Mr. Tagosan, who is I thought he included this technology for this country. Да, ну действительно, я хотел сказать, те, кто более программа, если вы видели, брать поэтапно. Вот дорога поэтапно. Старт планом, потом дальше, и уже конец. А кто был во Франции на аэропорте? И там, кстати, учитывать потоки воздуха, учить потоки, это уникально. В режиме онлайн. То есть не учитывать построить. А потом тут же рядом проектируется. И это позволяет. И самое главное, что я считаю, почему в России сейчас прогноз. Не надо строить и сразу 3D прогнозируешь, как строить, как учить. Mr. Fogler, thank you very much for your presentation. I hope you the future. Second presentation and more. But кто хочет сказать? Может быть, кто-то еще хочет представить это?
Да,
мы говорим, что страны, это основная, качество теплоэнергетики, Юридического университета. Проводим мы действительно онлайн-конференцию. Действительно, я бы хотел еще раз поблагодарить именно мистера Фогера, доктора Фогера, который именно привез. Это, он один из основателей этой технологии. Вот. И тот, кто действительно может это... Есть вопросы, пожалуйста?
Например. Да. Друзья, кто с нами был всю эту конференцию, можете задавать вопросы, просто вам нужно сверху экрана включить ваш микрофон. Если хотите, чтобы мы вас видели, включите камеру у вас и задавайте вопросы, пожалуйста. Вот, например. Мы вас видим, ну? Найдите тоже, кто готов из вас задать вопросы. Ну, дамы и господа.
Было все очень интересно и понятно.
Скажи мне английский.
Да, спасибо, что...
Скажи, благодарю за интерес, содержательный.
Спасибо. Товарищ.
Да, все уже. Желтое я все включил.
Там просто смотрят.
Уважаемые коллеги, Караганды, пожалуйста, задайте вопросы. Вам ответит мистер Фогель, ответит на все ваши вопросы. Вместе с профессором Тайбатаром. Да? Слушаем вас.
Нет вопросов. Нет вопросов.
Так, у нас будут какие-то вопросы? Накопились, нет? Я бы хотел тогда еще раз поблагодарить профессора Фогеля, за интересную презентацию, и вас поблагодарить за то, что приняли участие, моих коллег, которые выступали, наших гостей, которые приехали, наших гостей тоже. Thank you very much for your
Всем большое спасибо.